Hello everyone, so this is my attempt to get on the camera the water level, how to implement an underwater effect that divides on in front of the camera. So when my camera is above the water surface, it's normal like this, and when my camera goes below the water surface, you can see we have some darker shade under the water. So actually this is just an experiment I'm doing. It's not perfect, even the water surface material is not perfect, but I want to show you how to attempt something like this. So yeah, the important part is getting the underwater fog to change in front of the camera like this. So this variable water level, getting it to work is the main target here. So yeah, let's see how to do that. And this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. Right, so this is my survival project, and this is the ocean shader that I have. It's not very good, but that's what I have at the moment. So what I want to do is, like, as you can see, for this underwater part, I need to have some underwater effect instead of the, so here for the above the water part it should look normal, and underwater part, look, there should be some difference to show it as underwater basically. So actually there is a easier way to do this. For example, I can have two post-process volumes. First one is infinite extent or unbound, and then I can add a higher priority post-process volume which overlaps with the surface of the water, and below that then there I can add some post-process effects to show it like underwater. But the problem with that approach is, as you can see, my water level go up and down here like this because of the waves, and I don't really know how to take that into account when I use two post-process volumes. Therefore, I'm gonna implement a way based on post-process volumes to add some underwater effects using a single post-process volume. So right, hope that is clear enough. So okay, let's get started. Right, so I will create a new material. Let's call it MPP. It stands for post process volume underwater. Alright, here is the material. So I'll change the material domain to post process. Now here I can get a scene texture node and apply color to the emissive. Now here we got this error. Scene color lookups are only available when material domain is surface. So but my material domain is post process. When I have the post process material domain, I need to use post process input 0. So let's use it. Right, now it all fine. Okay, so the next problem is let's just show some difference. So let's make the underwater color more bluish. Like this. Make plot 3. Break plot 3. So to make it more bluish, I'll multiply the blue input with, let's say, 4. Actually, for the moment I only need to show some difference. Wait, that's, what if I reduce it? Oh no. Okay, let's increase this and overall color multiply with a lesser value, let's say 0.2. Alright, okay, so this is the way it's going to look underwater. So I'm not going to use this forever. For the moment I need to see the difference in the screen, so that's why I use this. Okay. Now for the post process volume, here under post process materials, let's add what we defined, mpp underwater. Now as you can see, everywhere is blue, which is not what I needed. I only want above the water surface to look normal and below the water surface should look blue. That's what I want. Right, so for that, first let's implement a simpler method. When my camera is below the water level, as I think this water level is 1. Right, so when my camera is below 1, it should look blue, and above 1 it should look normal. So how to implement that logic here? Right, we can have a lab break. This is the input B and this is the input A. Oh. Let's add a component mask to get rid of this issue. Float 4 and float 3 are undefined, but I think we only need RGB here. No alpha component required. Right. As the alpha value, well, if the alpha value is 1, it will look blue. If the alpha value is 0, it will look like this. Okay. Right. Now what? Let's try this. We can get access the camera position in world space using this node. Here I'm only interested in the Z component of the camera location, which means the vertical height, vertical location. So we can mask this to a component mask and get only the B, which gives me the Z component of the location of the camera, and then we can have a if node. Right. Oh wait, we don't really need this lerp node. We can directly use this. If A is higher than B, we can have this input. If A is equal or less than B, we can have this output. And let's connect this to the emissive color. We don't need this. Alright, now what's B here? Okay, it's 0. Right, now right. Now as you can see here, when my camera goes below 1, this everything becomes blue, and above it becomes normal. But still it doesn't account for this when the camera is in the middle. Yeah, it doesn't take that part into account. So how to account for that? Right, so in order to have partial effects, we can use we will have to use determine the pixels, each pixel's position in a screen. So we can access it like this: screen position. This is also gives this gives 2D coordinates, x and y. Y is the vertical component, so let's mask this and get only the G, right? And then forget about this part for now. Let's connect this and see any difference. No. Alright, let's promote this to a variable and I'll call it water level. Okay, and let's create an instance of this material, mpp underwater inst, and let's assign that instead of the material itself. Oh well, that complicates things. So let's try one for this. Oh, now everything is blue. So what if we try a partial value, 0.2? Now it becomes like this. Alright, so we need this effect starting from the below. So let's have 1 minus of this output, whatever the output we get here. Right. Okay. See, it's there. Now we need a way to find to align this level with this water level. Oh, this is hard. And also we need to combine it with the camera position as well. Right, so what if I add this to the camera position and use it? Alright, now see, when I go down you can see that effect is coming, but I think we need to change this water level to what? Right, so here if my values are correct, up to this level I should get blue. So to get blue, let's try increasing this value. No. Oh, wait a minute. This is also, this matters to the clipping plane of the camera as well. So what's the clipping plane? Right, anyway, let's try increasing this further to right. Let's set, go here and clip. Okay, near clip plane is 10. What if I set it to 0? Right, now it is like this. Okay, right, so when I look up I can't really see the water plane, so let's duplicate this. I could set this material to two-sided, but for now I'll duplicate this as like this because I'll explain it later, and set the Z scale to -1. Right, now from the downside also I can see the water level like this. Okay, so if I disable the post process volume for a minute, I can see the water level like this. Okay, now what? Now as you can see, when I go up and down, this level remains same. Well, actually now that I think of this, I don't think I can make it work with this approach. So what can I do? Right, well, we need to find out some values here. For example, when my camera goes to this point, this, yeah, at this point the camera should have the, well, I need to find out what the location of the camera is, the Z location. Right, for that let's go to blueprints, open level blueprint. In the event tick, we need a reference to our camera, so get player camera manager, get allocation, and let's print the Z component here. It's 3 now. Well, I need to slow down this a little bit. Alright. Wait, how can I slow down this? Well, let's create a custom phone class for this, otherwise things would be hard. Phone camera How can we edit this? No. Oh, P camera. Right. Now as the P camera. Okay, move forward. Will this work? I'm not sure. Let's see. Forward vector. Vector forward vector. Oh, we don't have a moment component here. Right. Let's add floating point movement. Max speed. I'll set to 1. I don't even see it's moving. Right, I can move up and down, forward and backward. Let's implement up and down as well. Well, let's use move right to move up and down. I just only want to test here, so what? Oh wait, I need to move up and down, so direction is 1. Okay, now let's slow this down like this, multiply it by 0.1. Right, now it's easy to manage. Okay, now you can see the values, the vertical value of the camera. So when I'm like this, it's 5 or 6.4, and when I move down, it's like this, it's 0.4, and when I move up, it's like this. So yeah, so what I want to do is, when my camera is like this, the water level that I get from the screen position should always match with this value. So that means I think 0.5, I'm not sure, so let's see. We can clamp the value I get here in between 0 and 0.5. Let's see. Oh, clamping doesn't work. Alright, in order to work clamp it to the midpoint, we will have to set this one to No, let's have a completely different approach here. This should be let's clamp this one between 0 and 0.5 and set the water level to 0. No, let's do it like this. Directly connect this here and water level set to 0.5. Right, now it's always like this. But we have a problem. In the C plane, the vanishing point is not 0.5. It's more like here. So it needs to be changed to, let's see, 0.4. Yeah, it's 0.4. Okay, so then yeah, then now you can see the water surface is always aligns with the post-process change edge, but it should the post-process volume start to activate when my camera is below 5. Yeah, below 5. So let's add another multiplier here like this, and another if B is 5, then A, this one like a constant. If A is larger than B, then it should be 0 definitely. If A is smaller than B, then it should be 1. Right. Now let's see. Oh, wait. Something is wrong. Oh wait, I think this needs to be interchanged. Let's see. No, something's wrong. All right, it should be like this. If A is larger than B, the outcome should be 1. And equal also 1. If A is smaller than B, outcome should be this, and this output should come here. Right, let's see. Now let's move down. Right, it is working. Okay, But the thing is, now we need to mask the surface area from this blue overlay. Also, when we are below the water level, we need to add to this surface area to this blue overlay. So right, how to do that? Wait, something went wrong. And one more thing. So actually, I kind of misunderstood this water level. This should align. This alignment, this value changes depending on the direction I'm looking at. So for example, if I'm looking at like this, it is, when I go below, it's kind of okay. But if I am looking above like this, now it's not okay. Even if I move down, now it doesn't align with the water level anymore. So this value should be calculated using the camera location, sorry, camera rotation. So let's print that here. Okay, camera rotation. I think look up and down value is on pitch. Yeah, let's see. Oh, I haven't implemented that yet. So look up, wait, I don't remember how to implement that. Let's check the, right, it is like this. Let's just copy. Cool, now we can look up and down. So when I below the sea level, if I'm looking directly forward, it should be 0.5. Wait, we can test it. I'll set this to 0.5. If I'm looking directly forward, it's, yeah, it aligns. If I look up, it should decrease. So when I look 30 degrees upward, it should be completely disappear. And when I look 30 degrees downwards, it should be completely, oh, 30 degrees becomes 328. So that value should be 1 if it is if I look down 30 degrees. Right, so how to incorporate that here? We can get camera rotation, can't we access that? We can get camera direction vector. Right, then what? Okay, let's print that instead of the rotation. Forward vector, direct, okay, forward vector, split and print is set component. Okay, when the directions Z component is larger than 0.5, the C completely disappears. When it is smaller than minus 0.5, it should be completely on the view. Cool. Now I can implement it here. Component mask, get only the Z component and add 0.5 to that. Right, and clamp in between 0 and 1. Then connect this one as a lerp input, node A as the alpha. No, we can directly use this as the water level, I think. Yeah, let's see. Okay, it should be 1 minus. Right. It aligns with the vanishing point of the sea. Cool. Alright, now the next challenge is how to get this variable component. Okay, for that let's use the custom depth buffer. Now I delete this ocean down. I don't think I would need it anymore, and I'll set this material to render 2 sides. Let's make it 2-sided, so I will be able to see that from up and down. Right, yeah, I can see that. Cool. It works in without the editor mode too. Right, now let's set this to render in custom depth pass the ocean. So if I go, yeah, can I visualize the buffers? Custom depth, oh, it's not there. Oh, why it doesn't show up in the custom depth? Let's check the material. Do we have any option? Oh, we have. Okay, we have. I think we have to enable this. Let's try that and apply. Right. Okay, now we can see that. Cool. Right. Now, let's go back to lit mode. And here we can get custom depth. See which node I should use. No, not this one. Scene texture. Oh, we have custom depth here. I hope I can use this in post-process material. Right. P must be type of float. Let's do a component mask and get only R. And let's clamp this output also between 0 and 1. Oh, not what I expected. Let's directly put the output of this custom depth R node just to see what we get there. Oh, it's all white. Why is that? Let's have a 1 minus. Oh, now it's all black. Okay, oh, here also it's all bad. Alright, I think for the depth value I get a larger value here. So we might need to divide this by something like 10,000. Yeah, exactly. Now it should work. Okay, now when I look from above, can see that. All right, now what else? But why this area is normal? Should I clamp this? Alright, that's the issue. Okay. Alright, so we have a small issue here, but let's address it later. Alright, so when I'm above the water level, this custom depth pass should be subtracted from the blue layer. When I am below, it should be added. So let's try something like this. Let's multiply this by, yeah, here we calculate the camera position. That's the threshold value we need to change. Now camera location. Oh, we need to print the camera location for that. Let's take as 9. Right. Let's have another if here, and A is this B, and B is 9. If A is larger than B, we should return -1. Otherwise, we should return +1. And compile. Well, wrong. Oh, actually we can't have minus values here, so that's a problem. Alright, so let's add this multiplication after clamping. Right. I think, yeah, I miscalculated this B. It should be 0, I think. Let's see. Yeah, it is 0. See? Okay. Now you can see the edge of the water, and it goes up and down as I move up and down. similarly here too. Like this. Cool. Okay, now we have a clear way to distinguish underwater and what is underwater and what is over the water surface. Okay, see, right, now let's add some effects. Alright, so what should we do under the water? Let's add some simple underwater fog effect. Yeah, right here. Let's have a vector parameter and float 3 club with this one. So as the underwater fog color, I'll use a color like this, and as the alpha value I'll choose scene depth. Well, this should be divided by some larger value, let's say 10,000, and clamped between 0 and 1, otherwise I will have unrealistic values. Right, okay, effect is too strong, I guess. No, actually this should be interchanged. This one should go up and this one should go down. So now in the distance I will get this color. Oh, that's too light then. Let's reduce this one. 4,000. Right, now I think it's alright. Alright, so here is the final preview. So when I'm above the ground it's like this, and when I go below you can see even with the water surface level change, the underwater part is visible with a darker shade like this. Actually it's not realistic, but I just want to show how to implement the change like this. right? And when I'll, yeah, basically that's it. And I'm gonna stop this episode right here. And still there is a lot of room for improvements, but I'm gonna stop right here because it's taken too long. And yeah, as always, the project files will be available for download in the Patreon page, and the link would be in the description below. And thanks for watching. See you in another episode. Goodbye.